Okay, so we just finished up chapter 13 trig, and chapter 13 trig was primarily if you went through our geometry program review. So in chapter 13 we looked at right triangles and doing SOHCAHTOA stuff, and then we looked at our law of sines and law of cosines and how to work in a non-right triangle. We have one more chapter of trig, and we're going to break it up into two chunks again and do a few lessons in a quiz and then a few more lessons in another quiz instead of doing one large test over everything. With trig, I like to do just a few lessons and frequent quizzes to make sure that we're staying on track, because it's the kind of thing that can snowball pretty fast if we start to lose track of it. So I like to do more frequent check-ins on that instead of just waiting and having one huge test on everything. So in this first group of lessons, what we're going to be looking at is graphing our three primary trig functions, sine, cosine, and tangent. We are not going to look at the graphs of the reciprocal functions, cosecant, secant, and cotangent. If you go into pre-calc, that'll be something you'll look at there. And we're not going to look at the graphs of the inverses, like inverse sine, inverse cosine, inverse tangent. Again, if you go on to pre-calc, you'll look at those in that class. We're just going to look at our sine, cosine, and tangent graphs. Today we're going to talk about sine and cosine, and these are the standard shapes of the sine and cosine graphs. Okay? Sine and cosine graphs are waves. Sine and cosine functions are extremely applicable in many, many ways. So a lot of times students don't like learning trig because it is kind of hard, but it's really applicable. So hopefully that can make you a little bit more interested in learning it. Anything that follows a cycle or a routine is able to be modeled by a trig function. So, for example, hours of daylight. Because sunrise and sunset times vary throughout the year, the number of hours of daylight vary throughout the year. And we have, in the summer, our longest amount of hours of daylight, and then in the winter we have our shortest amount of hours of daylight. But those go cyclically throughout the year, and we could model those hours of daylight by a trig function. You guys follow a cycle every single day. You go to the same 7 classes in the same order. So we could model something like that by a trig function. Okay? Anything that follows a routine and a pattern over and over and over can be modeled by a trig function. Our sine and cosine functions look very, very similar. They are both waves. We're going to distinguish 5 points on each of them to give them what I call their shape. For sine, it's going to follow the shape of what I call middle, up, middle, down, middle. Just kind of the location of those 5 points. Okay? So sine begins at a middle level and then goes up, back through the middle level to a low point, and then back to the middle level, and that completes its cycle. And it would repeat that same thing over and over and over. Cosine follows the same type of shape, but it begins in the up position and then goes down to the middle, all the way down to a low point, back through the middle, and back up top. Okay? So remembering those sequence of 5 letters is going to be important to being able to graph our sine or cosine function. Okay? Middle up, middle down, middle, or up, middle down, middle up. Okay? So remembering those sequences of the 5 points that characterize each of those curves is going to be an important part of graphing them. So in each of our questions when we look at graphing, I'm going to ask about the shape of it. That's what I'm talking about, is which is the sequence of points for that particular function. On the functions, there's some measurements that we take. The first one is called the amplitude. The amplitude is the height from the middle up to the high point. Okay? The amplitude is not from the high point to the low point. It's from the high point to the middle line. And that's how waves are measured, like in a body of water, too. They don't measure from like the low point of one to the high point of the next wave. They measure as if there were no waves, like that middle line, and how high is the wave going above what would be a normally flat surface. Okay? So when we talk about waves in a body of water, we measure it that same way, from the middle up to a crest of a wave. And so that's going to be called our amplitude, or our height. The second measurement that we care about for them is called the period. And that goes from the beginning to the end of one sequence of those 5 points. So how long does it take to do that one sequence of those 5 points? Okay. this gives some terms of those definitions I was giving. Our standard form of our equations is going to be a sine bx or a cosine bx. Okay, so the sine and cosine, the trig functions will change out. But either way, we're going to have this number a in front and b right with the x value. A affects the amplitude. That's going to be the height of our curve. Okay, so that number in the front of the equation is going to define the height of the curve. The number that is with the x is going to define the period of the curve. But it's not just that number, it's 2 pi divided by that number. Okay, so 2 pi divided by that number will give us the period length of our curve.
Is it absolute value? So
it is absolute value. Yeah, we're only going to be working with positive a's and b's today, so we don't really need to worry about that for right now. But yeah, it is absolute value. That's why those lines are there. Okay, so to graph a trig function, I'm going to be pretty picky about how you graph these trig functions. So much so that, like, in theory, when you hand in your papers, I should be able to like lay a transparency on top of it and everything's going to look exactly the same. I don't want sketches of the curves. I want them to actually be nicely graphed. So here's what we're going to do. And I'm going to do this on line paper because I have a feeling most of you are going to use line paper. If you use graph paper, that's totally fine too. But you don't have to use graph paper. With the method that I'm going to show you, you can just use line paper. So that's why I did this on lines instead of a graph grid. So we're going to create our x and y axis, and I'm going to put my y axis pretty far over just towards the edge of the paper. So we're only going to graph out in the positive direction for these. So for this, three things really that we're always going to want to consider before we begin a problem. The first thing is the amplitude. The amplitude is given by the number in front of the trig function. So for this one, our amplitude is 2. This one is going to have a height of 2 from its midline up to its high point. The next thing we're going to want to consider is the period. Our rule for period is 2 pi over b. B is a number that's in front of x. What number is in front of x?
Sine.
What number is right in front of the x? 1. There isn't one, right? So it's really just like a 1x. So we're going to have 2 pi over 1, or just 2 pi is the length that it's going to take for it to complete that cycle of 5 points. For our graph, I'm going to ask that you always do 2 cycles of your graph as long as that will fit on your page. Some of your graphs in your assignments are going to have a really long period length and you're not going to be able to fit 2 of them on your page, and that's okay. But if to fit on your page, I want you to do 2 cycles of each graph. So what we need to do is measure out to a 4 pi. How big is pi approximately? 3.14, right? So it's right about 3, a little bit more than 3. So what we're going to do is say each line of our paper has a height of 1. So I'm going to take 3 lines of paper, and I'm just going to kind of like measure it with a finger pinch and tip my fingers over and mark that out and say that's about the same as a pi. Okay? So I'm going to take my fingers, measure out the height of 3 lines with my fingers, tip it over, and I'm going to say that's pretty much a pi, because pi is pretty much about 3. So that's going to give us a nice equal scaling, that our x-axis and our y-axis match each other. Okay? If you're doing it on graph paper, that's fine. Have each box have a height of 1 and a width of 1. So going over 3 boxes would be about like going over pi. So that's going over 1 pi. Our period is 2 pi, and I said I want you to do 2 cycles of it. So we need to take this out to a length of 4 pi. So I'm going to take that same measurement of pi, and I'm going to count it over to 4 pi. Questions on how I want you to set up your axes and scale it.
So pi equals 3.
Pi is 3.14, so it's right about 3. So we're just going to approximate that at 3.
How did you get to 4 pi?
I took that same length, however long I used my fingers to measure out pi, and I just kind of kept going over that same amount. And I chose to go out to 4 because I want to do 2 lengths of my period.
Oh.
So since the period is 2 pi, I want enough room to do 2 cycles of it. All right, so now we need to start plotting some points, but we need to know what points to plot. So the third thing that you should always consider before you start graphing is the shape of the function. This one is a sine graph, so its shape is middle up, middle down, middle. That means our first point is going to go at the middle. When I plot my points, I do it from kind of an outside-in method because these graphs are completely symmetrical. So I'm going to graph that middle point first. So I'll put a 1 by that because I'm doing that first. The second point I'm going to plot is the very last middle. And that should be at the length of the period. So between your first point and your last point, you should have the length of the period. So I'm going to put that last middle point at 2 pi, since my period length is 2 pi for this problem. The third point I'm going to plot is the one right in the center of them. Because everything is perfectly symmetrical, that point should be perfectly in the center of those other 2 points. So it's going to be at pi. Oh, man. There's no way to get it back. I hit the wrong button. Oh. Sadness. Okay, so this is what we had plotted before I hit the wrong button. All right, so then the points that we still have to do are up and are down, and those are going to happen exactly in the center of those points we've already plotted. So exactly in the center of these first 2 middle points, we're going to have our up point, and we're going to go up to the height of the amplitude. So my up is going to be up at a height of 2, right exactly in the center of those first 2 points. My down is going to match it at a height of -2, exactly in the center of those other 2 points. Connecting these with a smooth, rounded curve creates a sine graph. Sine graphs are not pointy at all. They are completely smooth and rounded, so don't let me see V's on these graphs. Okay. Completely smooth and rounded. That's 1 cycle of our graph. I'm going to ask that you do 2 cycles as long as 2 fit on the page. It's going to look exactly the same. So we're going to plot the same sequence of 5 points to just draw 1 more perfectly matching wave. We want to put arrows on the ends of it because it goes on forever. We're drawing 2 cycles, but this really has infinitely many cycles in both directions. So we're going to put arrows on the end of that. I'm sure this is fairly uncomfortable at this point, so we're just going to mosey on to another example, and things will become more comfortable the more that we do. So the things we always want to consider before we begin a problem, the amplitude. The amplitude is given by the number in front of the trig function. So what number is in front of the cosine?
1.
A 1. So our amplitude on this problem is 1. The period is 2 pi divided by b, where b is the number that's right in front of x. So what is b?
2.
2. 2 pi divided by 2 is just pi. The third thing that we'll need to consider before we can plot points is what kind of a trig function we have and the shape of that function. This is a cosine, so it's going to follow an up, middle, down, middle, up pattern. Then I'm going to create my axes the same way, using my fingers to just kind of roughly measure out 3 lines of my paper, tip it over, and I'm going to call that a pi. I want you to go far enough that you can fit in 2 complete cycles, and a cycle takes up a length of a period. So if the period is pi, I need to go out to 2 pi on this one, so I have enough room to complete out 2 of those period cycles.
Can you go that again? Why you have to double it?
Yep, that's just something that I'm specifically asking you to do. The book actually asks you to only do 1 cycle, but when you do your homework, I want you to draw 2 cycles. So we're doubling it so that we have enough room to do 2 patterns of it. I like to have students draw 2 patterns of it so that we can see that this is very repetitive in nature, that it's going to keep on going and going, instead of just seeing 1 at a time. So then we're going to start plotting some points. For cosine, and I plot them in the same order from kind of that outside in manner. So I'm going to start with my up point. My amplitude is 1, so I'm going to start up at a height of 1. Then I plot out the very last point, which is another up, and it's going to be pi away in this problem because that's the length of the period. So over at pi, I'm going to have another up. Exactly in the center of those, I'm going to have my down, and it should be down just as much as the up, so I'm going to go down 1. And exactly in the centers of those, we have to cross through the middle if we want to be able to get from up to down. Cosines in particular for students usually end up looking a lot more pointy because this looks like a V when we plot those 5 points. So make sure that you concentrate on when you're connecting your points that you do so very rounded. And then do 1 more exactly matching set of the 5 points. Once again, it should have arrows on the end. Be careful with cosine. It froze. Be careful with cosine that your arrows are pointing back down. A lot of students have them pointing straight up. Reconnecting.
Where's heaven pointing down?
The arrows at the end should be pointed down. It's reconnecting, and I'll get my drawing up there in a second. Assuming it reconnects. Okay, so make sure that those arrows at the end. It's still not drawing? Really? There it goes. Make sure those arrows at the ends are pointed down. A lot of students want to just kind of head on through those up points and have the arrows pointing up, but the up is as high as it ever gets. So that arrow has to be pointing down instead of it go through another cycle there. All right, so for this one, same questions. Amplitude is going to be a half. Our amplitude is given by the number in front of the trig function. Period, 2 pi over b, and b is 1, the number in front of x. And so if there is no number in front of there, it's just a 1, and our period is 2 pi. This is a cosine graph again, so we're going to do an up, middle, down, middle, up pattern. Three lines of paper, tipped on its side, makes a measurement of approximately pi. And on this problem, we're going to want to go out to 4 pi, twice the length of the period, so we have enough space to fit in 2 cycles. Since this is cosine, it begins in the up position. The amplitude is 1/2, so it only begins up 1/2. At the end of the period, it ends up also at 1/2. In the center of those points, it has its down a half. And it has to cross through the middles to be able to get from the ups to the downs. So this graph is very short in height. Okay. It has kind of an average period length. 2 pi is kind of our normal average plane period length, but it has a very short height. Okay. And then we're going to do the same exact cycle one more time. Musical notes can be modeled by sine or cosine functions. The amplitude is the volume of the note, so this would be a quiet note. Okay? The volume is the amplitude. The shorter that wave gets, the quieter the note is. The taller that wave gets, the louder the note would be. What do you think the period would be? Good thought. The pitch of the note. So as we shrink down that amplitude and we're getting a lot more vibrations, that's going to be a higher pitch note. As we stretch out and we have a longer period length, that's going to be a lower pitch note. So musical notes can be modeled by trig functions. In this example, what is the amplitude? 1. And the period is 2 pi divided by what?
Half.
Divided by 1/2. How do I divide by 1/2? Multiply by 2. So this period length is 4 pi. I think I am only able to fit one of these onto my page. I think you can fit 2 of them onto your page, but you don't have to. I think on my slides, I really only have enough room to fit one of these onto my page. So that's what I mean on your homework. If you can fit 2, I want to see 2, but if you can only fit 1, then just do 1. Our sine graph follows a pattern of middle up, middle down, middle.
Did you multiply by the reciprocal to get?
Yep, since I was dividing by a fraction, I turned into multiplying by the reciprocal.
How do you know what pattern to use?
Sine and cosine each have their own pattern. So at the very top of the notes, there's the 2 kind of plain pictures. And sine will always do that middle up, middle down, middle. And cosine will always do the starting up. Yep, so that's the type of the trig function. All right, so to plot points, sine begins in the middle, so that's going to be right at the origin. It ends at the length of 1 period back in the middle. So over at 4 pi, it has its ending point. Exactly in the center, it has another middle. And between the first middles, it has an up. The amplitude is 1. So we're going to do a height of 1. And between the last middles, it has a down. So we're going to do a down of 1.
Are you just not having us double it because it's too big?
I just don't have room. Yep. So do 2 if you've got room. I think you have room on your paper, but I don't have room. So you can just do 1 here. On your homework, I believe there's one that has a length of 10 pi. You will definitely only fit 1 of those on your paper. Okay. So when it gets a really long period length, then you can just deal with 1. Questions? Okay, for this one, amplitude. 1/3 is not going to be very tall. This is going to be a very, very short in height graph. So thinking about music, it would be a very quiet note that's being played. The period is going to be 2 pi divided by pi. 2 pi divided by pi is 2. And the pi's are just going to cancel each other out there. This is a cosine, so it's going to do an up, middle, down, middle, up. Now in making my axes this time, our period does not care about pi's. The period is just 2. So instead of marking out where pi is, I'm going to mark out where like 1's are. So since my period's 2, I'm going to take 2 lines of my paper and flip it over and call it a 2. I don't care where pi is on this one because the period doesn't have a pi in it. Normally, your periods will have a pi in it, so that's why we measure out pi's. But on this one, it's just a plain 2, so I'm just going to take 2 lines of paper and call it a 2. And I'm going to go over to 4 so that I have enough room to fit in 2 of them. Then I'm ready to plot out some points. This is cosine, so it's going to start in the up position, but only up 1/3. Above 2, it's going to be up 1/3. And right in the center of that, where 1 would be, is going to be down 1/3. And that's to go through the middles. This is just a tiny graph. It's short in its period and it's short in its height. So this would be, in terms of music, a very quiet, high-pitched note. Like dogs beware. Copy that cycle one more time. Again, with cosine, make sure that you're concentrating on pointing your arrows at the ends downward and not just having them head on up above that point, because it never gets higher than the up point, so those arrows need to be pointing down so they could go through another cycle.
Just for cosine?
Yeah, because sine, they're heading in the right direction already, heading through the points. So you just kind of continue on through the points in sine. And then cosine really concentrate that they're heading down.
I'm so tired. Good job.
No.
One more example. What's the amplitude? 2. The period is going to be 2 pi divided by what? What number is in front of the x? So it's x divided by 4. What's another way of writing that? 1/4 times x. So this is going to be 2 pi divided by 1/4. If I divide by 1/4, that's the same as multiplying by 4. So my period is going to be 8 pi, and I don't have enough room to fit that on my paper. So I'm going to have to make an adjustment to this graph. Before I do that, this is a cosine. So I'm going to go up, middle, down, middle, up. The adjustment that I'm going to make to this graph, to keep my axes measuring the same kind of things, I'm going to adjust both of them so that I'm counting by 2's for each line of my paper. So when I tip over 3 lines of paper, instead of being a pi, it is a 2 pi. So you may adjust your axes as necessary to be able to fit in your graphs, but make sure that you adjust both of them. Okay? So I'm going to adjust my height to count by 2's and my length then as well. So 3 lines instead of making 1 pi makes a 2 pi. My amplitude is 2 and I start in the up position. Be careful, that's really only 1 line of paper because we're counting by 2's here. At the end of 1 period, which is all the way over at that 8 pi, I only had room to do 1. It's back in the up position. And halfway between, it's in the down position. In the center of those, it goes through the middles. In terms of music, this would be louder because it has a height of 2, and it is a very long period length, so this would be a low-pitched note. Questions? Your homework is from 14.1. In that homework, you're going to have some matching problems. And in some of the matching graphs, you're going to see something that looks totally different than what we did today. Those are not going to be your answers. Okay? We haven't talked about how to graph tangent yet. Tangent looks very different than sine and cosine. So in some of your matching questions, if you're like, what? She didn't do anything like this. Then that's probably not going to be one of the ones you're going to want to pick for a matching answer. Okay?